So let's go ahead and get started. Welcome back, CE 528. We're talking about the dual problem, a transportation problem, and its corresponding dual problem. So let's think this through. So what's happening here is that you are trying to, the problem is to try to minimize the total shipping cost. And here is the problem. You have three sort of warehouses, okay, or three origins, and you have four destinations. Okay, so three origins to four destinations. And you are trying to figure, and then you are given how much does it cost to go from each origin to each destination. Okay, so you know that if you're trying to go from S1 to D1, it costs $35. If you're trying to go from S1 to D2, it costs $30, and it could be 30 cents, whatever, 30 units. And then if you're trying to go from S1 to D3, it costs 40 units. And if you're trying to go from S1 to D4, it costs 32 units, and all the corresponding costs are given to you. Are you guys all able to see this on your screen? What you might want to do is you might want to pin the camera for DocCam, please, on your screen. Okay, so you might want to pin the DocCam user onto your screens. I think that will make it easier. Is everybody able to see the cost? It might be a little bit fuzzy, but hopefully not too bad, and you can see it. If you can see it, give me a little thumbs up, please. Okay, perfect. Thank you, Katie. And I'm hoping that Katie doesn't have the sharpest eye and everybody else can see it as well. Thank you. All right, perfect. So, and again, this is also available on your Canvas page, so you can look that up there as well. So, and then the other thing, so you're given these individual costs. So your job is to minimize the total shipping cost. And so you're going to try to figure out how much stuff you should ship from S1, how much you should ship from S2, and how much you should ship from S3. And then correspondingly, how much should go to D1, how much should go to D2, how much should go to D3, and how much should go to D4. Okay. And now, if you had no constraints whatsoever, and you're looking at these costs, can you tell me where would you ship all of your stuff from and to? Where would you pick? So what you will do in that case, you will just pick whichever route has the absolute minimum cost. Can you tell me which route has the minimum cost, if you can see it? Which of these OD pairs have the least cost? Okay, I'm going to let you know. So the answer to that question is 15, right? So if you go from S3 to D2, it only costs 15 cents according to this right here. So what I would do is that I would just go ahead and ship everything from S3 and D2. I'm not going to even bother with any of the other routes. I'm just going to keep whatever gets in S3 and whatever gets to D2, and then ship everything to D2. But I do have some constraints here. And those constraints are that S1, that S3 can only produce 800 units of goods that I can ship. S2 similarly can only produce 1,000, and S1 can only produce 1,200 goods that I could produce at these three locations, at these three sources, okay? And destination, each of these destinations also have a constraint in that all of these destinations require a minimum amount of number of stuff that goes to those locations. So D1, at least, this first destination needs at least 1,100 units. And then the second, the D2 needs 400 at least, D3 needs at least 750, and D4 needs at least 750 as well. So my total amount of stuff that I have that I need to produce is 3,000. And it looks like it's a balanced demand and supply. They both add up to 3,000. So I have 3,000 units of good that are going to be produced and going to be shipped to the destinations. But I need to make sure that I am shipping them at the least possible cost. Okay. All right. So let's think this over and figure out what's going to happen here. So first of all, I'm trying to figure out, so for example, the goods that are going to be shipped from S1 to D1, let's call it X with a subscript notation of 1, 1, where 1 denotes the origin, the first number denotes the origin, the second number denotes the destination. So this number, so if you are shipping X11 goods from S1 to D1, your total cost of shipping just those X11 goods will be 35 times X11. Okay, because the unit cost of shipping, so these 35, okay, all these numbers are the unit cost. So 35 is equal to the unit cost of shipping. Right? 35 is the unit cost of shipping. And then similarly, 30 is the unit cost of shipping from S1 to D2. So this is 35 is the unit cost of shipping S1 to D1. Okay, so that means how much would it cost you to ship 1 unit? So if you're shipping X11 units, it'll be 35 times X11. Now my question is, with what variable, if you know, understand this notation, what variable would you use to denote the stuff that goes from S3 to D4? What would you denote? What variable X, what will be your subscript for S3 to D4? Type it up in chat, please. Okay. So you're exactly right. X34 was the cost of, is not the cost, but the units that I'm going to ship from S3 to D4. I'm going to denote it with X34. So this way I can write the total cost equation by multiplying unit cost with number of units shipped on each OD pair. Okay, so that's why I'm getting 35X11, 30X12, 40X13, 32X14, and so on and so forth. I'm going to add all of those up. Now the question for you is, I want to minimize this total cost. That's what the transportation problem is, right? Minimizing the total shipping cost. Okay, and the other thing is the question of how many decision variables then I have. How many decision variables I have here? Decision variables are the number of variables that you're trying to decide on, that you control, so that you minimize your cost total. So this is what we call our objective function. My question to you is, how many decision variables you have? In the chat, thank you, Dana. So yes, that's exactly right. I have total 12 decision variables because, see, I'm trying to decide how much stuff to ship on each of these OD pairs, right? And I have 3 origins, 4 destinations, 3 times 4 is 12. So these X11, X12, X13, all of these X's are my decision variables. And then I have how many total constraints. Now I'm going to start looking at constraints now. Okay, if I'm going to start to look at constraints, that the constraints are going to come from how much goods can you get from each supplier and how much goods each destination actually needs. Okay, because so that means the total number of goods shipping from S1 cannot exceed 1200, right? Because that's the capacity of the first source. So that means my first constraint will be X11 plus X12 plus X13 plus X14 less than or equal to 1200. And similarly, my second one cannot ship more than 1000, and the third one cannot ship more than 800. So I can write those X21 plus X22 plus X23 plus X24 has to be less than 1000. And similarly, I can write the third one. And remember, these constraints are all less than or equal to these. That means I cannot violate the capacity constraint of each of my origins. Right? Now, let's think about the last 3 constraints. My last three constraints are about the demand side constraint. The first destination needs at least 1100 units. It needs at least 1100 units. So that means whatever gets to D1, from all of these origins, whatever gets to D1 has to add up to 1100 or more. It can take more, but it needs at least 1100. So I can write, so my constraints will be x11 plus x21 plus x31 greater than or equal to 1100. Now, what I want you to do is, I'm going to hide this, and I want to give you 1 minute to write down the constraint corresponding to D2. So in your notebook or in the chat, write out the constraint corresponding to D2. Okay, what is going to be the constraint corresponding to D2? D2 needs at least 400. Okay, so take a minute to see if you can write that out. Okay, that's good. Thank you. So at least I see one solution from Dana. So thank you very much, Dana. I appreciate that. So yeah, that's right. So what you have is correct. So first, to write these constraints, first you have to think about what stuff is coming to D2. So from here, from this arrow, this path, I've got x21 coming to, x12 coming to D2. From this second path, I have x22 coming to D2. And from this third path, I have x32 coming to D2. Okay, so what has to happen is x12 plus x22 plus x32 has to be greater than or equal to 400. Okay, and that's exactly what I have here. x12 plus x22 plus x32 greater than or equal to 400. And then similarly, I can write the third and fourth one because, and then remember the destination will always be 3 here. So x13 plus x23 plus x33 they have to add up to at least 750 or more. And then x14, x24, and x34 also have to add up to 750. That makes sense? Questions about this? Okay. There are no question about this. So there were 12 decision variables, 12 DVs. And how many constraints I have? 1, 2, 3, 4, 5, 6, and 7 constraints. 7 constraints. And if I want to write it in a standard formation, this is a minimization function. The minimization function. So I can, if I want to write all the constraints as greater than or equal to side, so then what I'll do is I'll take first of these 3 and I'll multiply these by -1. Okay, multiply these by -1. So I'll get x11 minus x12 minus x13 minus x14. And I'll be able to write this, flip the sign of this inequality greater than or equal to, and I'll be able to write 1200. Okay? Or negative 1200. Okay. So remember, when you multiply by -1 or any negative number on an inequality, the sign flips. And that's, so basically because this was a minimization problem, I'm going to write all my constraints in the form of greater than or equal to. And then it's the same constraint still. And then same thing with x21 minus x22 minus x23 minus x24 has to be greater than or equal to negative 1000. Okay, negative 1000. And then similarly, x31 minus x32 minus x33 minus x34 should be greater than or equal to negative 800. Okay. And I did that -1 multiplication because I want all my inequalities in the greater than or equal to 4. Okay. Now you can actually set this up in Excel and solve it. Okay. You can set this up in Excel and solve it. But that's not something that I'm trying to write out right now. What I want to do instead is I want to take the formulas that we had and I want to write the dual problem. Okay, so I want to write the dual problem of this. Okay, So remember, I have 12 decision variables and 7 constraints. So that means in my dual problem, I'll have 7 decision variables and I'll have 12 constraints. That makes sense? Right? So remember that. Right? So what I'm trying to do now is that I'm going to write this in matrix notation, and then I'll be able to hopefully write the dual problem. So remember my original problem then, and I'm going to write this problem down here. If I look at these equations, so my X looks like, if you recall from our last lecture, let's go ahead and start the record button. So we were writing we had the original optimization problem. We wrote down the equations for all the constraints, and then we multiply the constraint equation by -1 so that we can get that minimization problem. We can get that minimization problem in the standard form with all of our constraints being greater than or equal to. So we multiply both sides of the first 3 constraints with -1. We wrote those out. We had 12 decision variables and 7 constraints. And then recall that, if you have a standard minimization problem, you'll have minimization of z equal to cx such that a times x is greater than or equal to b, and x is all greater than 0. Okay. And then I'm trying to write what these c's and x's are going to be. My x's is going to be n cross 1 matrix, or you can call it n cross 1 column vector. And then this is what it looks like: x11, x12, x13, and so on and so forth. And then my C matrix will be a row matrix, a row vector, you can call it 1 cross 12 row vector, because it only has 1 row. It'll be 35, 30, on and on and on, and 20 and 28. And then this is basically each of these cost of shipping on each OD pair. And I can write that down. And now the question is, the size of A will be 7 cross 12. It's M cross N, where M is the number of M is the number of constraints. And N is the number of DVs, decision variables. And I have 12 of those, and I have 7 of those. So it's a 7 cross 12 matrix. And that's what I was trying to write out before my phone just shut down. So I'm trying to write for the first constraint. Remember now, the first constraint now looks like this one: -x11, -x12, -x13, -x14. And then there is no coefficient for all the remaining decision variables. So I can almost say that this represents x11, this represents x12, x13, and x14, and then x21, x22, x23, x24, and then this is x31, x32, x33, and x34. So you are writing down coefficient corresponding to each of these 4 variables along these lines. And I start with 4 -1s, then a bunch of them zeros. So that's my first row. My second row would look like zeros over here, and then 4 -1s. And then the right-hand side would be 0 again. And then my third row would be first 8 zeros. Okay. So this basically confirms the left-hand side. This writes out the left-hand side of first 3 constraints. First constraint, second constraint, and the third constraint. Okay. And that's what I've written out over here. Make sense? Questions? No questions? Any questions? Now, the second constraints are a little bit tricky because I have to put coefficient corresponding to x11, x21, and x31. So I need coefficients corresponding to x11, then I need coefficient corresponding to x21, which is right here, and then I need a coefficient corresponding to x31. And what is that coefficient? It's just ones, right? 1 times x11, 1 times x12, 1 times x13. Or x31, sorry. 1 times x11, 1 times x21, 1 times x31. So I need constraint corresponding to 1 here, and then 1 over here, and then 1 over here. And then what do I need? I need rest of them to be zeros. Make sense? Any questions? So remember, I'm writing 12 elements in each row, and each of those elements represent the corresponding coefficient for the corresponding variable, decision variable, in each of these constraints. The coefficients are 0 for a bunch of these things. Remember, this one also has, if I'm not writing down the next one, I need the numbers corresponding to x12, x22, and x32. So I need numbers corresponding to this one, x22, this one, and x32. So these are the 3 where I need the ones. The rest of them will be zeros. Okay. So now I've written out 5 rows, and I need 2 more, right? I need 2 more, and then those 2 more can also be written out like this. Okay. Now, if you're daring, could you take a minute to write down the last one? You take a minute to write down the last one. It has only coefficient corresponding to x14, x24, and x34. So x14 is right here, x24 is right here, and x34 is right here. So that means I have no other coefficients left but for x14, x24, and x34 in this last constraint. You can write them down. I'm going to start writing all the zeros, and you tell me which of these zeros should I replace with 1. So I wrote out all of these zeros, but that's not correct, obviously. There will be 3 of these zeros that need to be converted into 1s. Which one? I'm going to go over and you tell me, give me a thumbs up if you see my pen on a place where I need to replace. Should I replace this one? This one? Give me a thumbs up if you see a number. This one? What about this one? Okay, I see 1 thumbs up there. Anybody else? Okay, so yes, that's correct because it's a coefficient of x41. So this should be converted into 1. This should be written out as 1. And then which one? This one? Give me a thumbs up whenever. Next one. This one. What about this one? Remember, I need a coefficient x24 coefficient to be 1 because it's x24 is my. So yes, so this should be also converted to 1, written out as 1. And then the last one also should be 1 as well, right? Because that will be the coefficient corresponding to x34 here. Okay. So what I've done here is that I've written out a matrix A, which is a 7 cross 12 matrix of the coefficient that make up my constraints. And then AX has to be, A times X has to be greater than or equal to B. These are easy to write. The size of B is nothing but 12 cross 1. The size of B would be 12 cross 1. Okay, and then that, I'm sorry, 7 cross 1. 7 cross 1. Okay, so size of B will be 7 cross 1, and that will represent the right-hand side of each of my constraints. So then my B matrix, or B vector, would look like 7 cross 1, and that will represent the right-hand side of each of these constraints. So starting with negative 1200, then negative 1000, and negative 800, and then 1100, 400, 750, and 750. So first 3 are negative because these are the right-hand side over here, and then the last 4 are positive, same exact numbers. So now we figured out in this original thing, we figured out C, we figured out A, we figured out B. And if we know some matrix multiplication or manipulation, we are ready to write down our dual problem. Remember, if you know C, A, and B matrices, you can write the dual problem as maximize Y equal to B transpose W such that A transpose W is less than or equal to C transpose. Where the W's now represent my new decision variables. W's now represent my new decision variables. And we know A, C, A, and B. We already know what those matrices look like. So now we can do A transpose, we can do C transpose, we can do B transpose. The question is only what my W's might look like. How many decision variables would I have in my dual problem? So this is what the dual problem would look like. How many decision variables would I have in this dual problem? Remember, I had 7 constraints in the original problem that I showed you. How many constraints would I have now? Or how many decision variables would I have now first? So that will be the size of my W. You can also figure out that size by looking at B transpose. Remember, B was a 7 cross 1 matrix. So B transpose will be 7 cross 1. Now, if you want to multiply this, okay, so I want to maximize this. So that means because the B is size 7, so that means I have 7 DVs. And then if you think about how many constraints you're going to have 12 constraints. And this is sort of my, not exactly an assignment. I'm not assigning a homework as in, but what I want you to be able to do is write out the corresponding dual problem. It will take some time to do it, but we did an example in the last class. It's a little bit bigger problem, but you should be able to write down the dual problem on your own by using this matrix algebra. Okay, and I'll give you some information about. I'll provide a matrix multiplication video, and I've also provided. When you look at the last lecture, you'll be able to see how do we apply these things so that we can write down the dual problem. All you'll need to do is transpose some matrices, multiply some matrices, and you'll have W1 through W7 will be your constraint. Now, I'm sorry, decision variables, and you'll have 12 total constraints. Okay. Now, what I've also done, I'm going to share my screen for a real quick. So I'm going to go ahead and share my screen. What I've also done is that how do you actually apply solver? And you can go back and remove the pin for the document camera. You can remove that pin now. But what I've done is on your 528 class Canvas page, I have provided you some instructions via a YouTube video that I recorded earlier as to how actually do you solve this transportation problem and its corresponding dual problem using Excel. Okay, so in Excel, there is a tool called Solver, and you can use that tool to solve our optimization problem. So what I want you to do is, before the next class, I want you to take some time to write down the dual problem and watch this video and see if you can get if you can solve this corresponding dual problem. And what I've done is I've posted the solution. And if I go back to the document camera, I stop sharing. I'm going to go back to the document camera. So if you want to pin that, I've given you this answer to the total shipment cost, the minimum total shipment cost of 84,000. So what I want you to do is watch the YouTube video that I posted that I just was showing you on the Canvas page and solve this problem using Solver. And then also watch the video for the previous lecture and use that video to write down the corresponding dual problem for this. Okay, write down the corresponding dual problem for this. And then use solver to solve the primal problem. Okay. Now, what I want to do is I want you to think about the dual problem, right? Dual problem will have 7 decision variables and 12 constraints. And what is the interpretation of that? What does the dual problem mean? So in the primal problem, what a primal problem means, the problem that I was describing originally, this particular one, what this problem means is that you're looking at it from a manufacturer's perspective as to what happens, how do they minimize their total shipping cost? Okay. And when you have a maximization problem, when you try to maximization problem, when you have the dual problem, so in the maximization problem, what you're doing is you're trying to maximize your profit. You're trying to maximize your profit by buying some goods over here, okay, and selling some goods over here at this destination. Okay, so you're a different entity now. When you look at it, the dual problem, it's an entity, but it's a problem from a different entity's perspective. And that entity, that mysterious entity, let's call it some firm. It's a firm that buys the stuff here and sells the stuff over here. Okay, so it has 7 decision variables, and those decision variables represent the price that you want to pay over here to buy the stuff, and the price that you want to pay over here to sell the stuff. So those are your 7 decision variables. The purchase price at S1, purchase price at S2, purchase price at S3, and then selling price at D1, selling price at D2, selling price at D3, and selling price at D4. So those are your 7 decision variables, okay? And then your constraints are that whatever purchase price you charge here, or whatever price you buy here, and whatever price you sell here, that price cannot exceed the shipping cost on this link. That difference in price, the difference in price cannot exceed the shipping cost. Why can it not exceed? Because then nobody will sell you, right? Nobody will sell you any stuff here, because the difference between the 2 prices cannot exceed the shipping cost. Because if it exceeds the shipping cost, people will say, hey, why would I sell you that stuff? I will pay the shipping and I'll sell it myself over here and make more money that way. So you're trying to maximize your profit by buying stuff here and selling stuff here, okay? And then you know exactly how many units you're buying and selling. So but your profit of buying and selling will be 1200 times S1 and 1000 times S2 and 800 times S3. Okay, so if S1 and S2 and S3 are your purchase price at these, and then by selling, you'll use D1, D2, D3, and D4 are the prices. So those are your 7 decision variables. And then once you write down the constraints, you'll see that the constraint will be the price differential, and you cannot charge a price differential more than 35 units, because then people won't sell you actually the stuff over here. Okay, so that will give you your 12 constraints. Each of these constraints will correspond to these individual shipping costs. The unit price differential cannot exceed the shipping cost. Okay, so what I want you to do is, I want you to practice writing the dual problem for this using the principle we laid out in the last lecture. And then you will see the 7 decision variables and 12 constraints. I want to write that out. And then watch the Excel video, watch the video that I provided on the Canvas page, and see if you can get the answer. See if you can get this exact answer for your primal problem. Okay, so go ahead and solve that and then write out the dual problem. And what I'll do is in the next class, I want you to have that dual problem and we'll start that discussion back up from that dual problem. Okay, and I want you to use that time to write this up. So it might take some time to do it because you might have to watch the previous lecture and this lecture. But once you do that, once we have the dual problem at hand, so make sure that you have that at hand in the next class because that'll really help the understanding. And then we'll start from that dual problem. And then once we have that dual problem, we can kind of go over the interpretation one more time. With that, actually, I'm going to stop here today. I'll give you some time to get to the farmer's market. And unless you guys have any questions, I'll see you guys on Tuesday or earlier if you have any questions. Okay. Thank you very much.